Welcome to the analytical geometry section. This section is relatively short compared to a lot of the other topics, so this shouldn't be such a long video. That being said, here's the topics to be covered. First, we'll do a bit of revision related to the things you've covered before. Just for some context, analytical geometry relates to the study of shapes using a coordinate system, more specifically Cartesian coordinates. And what that basically means is looking at shapes using x and y axes. At grade 12 level, you'll just look at two-dimensional shapes, so you only need x and y axes. But later on, at university level, you actually move a little further and look at three-dimensional shapes, meaning you would have an x, y, and a z axis as well. But in your case, it's just x and y axes. So as I said, it relates to the study of shapes using the x and y coordinate system. Next, we'll look at the equation of a circle and how a circle is modeled using x and y coordinates. And lastly, we'll look at how to determine the equation of a tangent to a circle at a specific point. And those are all the topics. Let's begin. First, let's revise some important concepts you've covered previously. Say you have 2 points, one with coordinates x1 and y1, and another with coordinates x2 and y2, and both of these are joined by a line. You can determine the gradient of this line using this equation, where m is used to represent the gradient and will be used in this manner throughout this video. So the gradient m is equal to y2 minus y1 over x2 minus x1. And note, the specific order of which one is subtracted from which one doesn't matter. You just have to make sure you follow the same pattern for the numerator and for the denominator. What that means is, it isn't only calculated by saying the point to the right, meaning this one with x2 and y2, is what you start with at the numerator and denominator and then subtract the previous point. You could have also said y1 minus y2 over x1 minus x2. You'd get the exact same answer for the gradient, but you just need to make sure you follow the same pattern for the numerator and for the denominator. Then next, if you want to find out the length of this line, which can also be thought of as the distance between 2 points, you can calculate it using the equation d equals to square root of x2 minus x1 squared plus y2 minus y1 squared. Again, there's a similar idea as for the gradient. You could have also said x1 minus x2 squared plus y1 minus y2 squared. You'd also get the same answer. Just make sure to keep the pattern consistent for both brackets. Next, if you want to find out the midpoint of this line, meaning which point is exactly between these 2 points, you'd use the following equation. x1 plus x2 over 2 for the x-coordinate of the midpoint, and y1 plus y2 over 2 for the y-coordinate of the midpoint. So it's just basically saying the average of the 2 x values and the average of the 2 y values. Then moving on, you've also learned how to model a line using an equation. And say if you have a line such as this, which intersects the y-axis at a point C, then the line can be represented using the equation y equals to mx plus c, where m is just the gradient as calculated before, and y and x stay as is, and c is the y-intercept as just mentioned. Another thing you've learned is how the gradients of numerous lines can relate to each other in specific cases. The first such case is for parallel lines, meaning 2 lines moving in the exact same direction, and if they were to continue forever, they would never ever meet. And the way the gradients of parallel lines relate is the gradient will be equal for all straight lines parallel to each other. Then the other case is perpendicular lines, which refers to lines that have an angle of 90 degrees between each other. And if one of these is called line 1 and the other one is called line 2, then the gradient of one line times the other line will equal to -1. Then the next thing to know is a Pythagoras theorem. And if you've already watched the Euclidean geometry video, then you should already be familiar with this. But if you haven't, what it basically states is that for a right angle triangle, meaning a triangle where one of the angles is 90 degrees, And this fact is very important, as the Pythagoras theorem only applies to triangles with a 90-degree angle in them. Where if the two lines that join together to make the 90-degree angle are named as A and B, and the side opposite to the 90-degree angle, meaning the hypotenuse, is labeled using the letter C, then by the Pythagoras theorem, C squared equals to A squared plus B squared. And that's the basic idea. Then the last thing to revise is related to the angle of inclination. And what that refers to is, when you have a line that cuts the x-axis at some point, the angle of inclination is the angle between the line starting from the positive x-axis, meaning the right side of the x-axis, and moving in an anti-clockwise direction till you reach the line. So just be very familiar with that description and what it implies. So for example, in this case, this angle wouldn't be the angle of inclination, because even though you'd be going in an anti-clockwise direction, you'd be starting from the negative x-axis direction, meaning the left side. So you think of the x-axis relative to the point where the line touches the axis. You can think of the point where it touches as the origin. So this would be the positive x direction, and that would be the negative x direction. So this angle would start at the negative x direction and move anti-clockwise till it reaches the line, which doesn't work with the definition, which states that it's the angle starting from the positive x direction and not the negative. And then it wouldn't be this angle, because even moving in the anti-clockwise direction, this angle would start at the line and not at the x-axis. So it violates the rule that way. But then you could say, oh, but then you could also look at it from this way if you wanted to start from the x-axis. But then in that case, if you look at it this way, it would be moving in the clockwise direction and not the anti-clockwise. So that violates the rule. And then it also can't be this angle, because that would start from the negative x-axis direction for one, and it would also move clockwise. Or then if you look at it this way, it would start at the line this time and not the x-axis. So that also violates the rule. So yeah, the angle of inclination is the angle the line makes with the positive x-axis direction moving anti-clockwise. And then this funny symbol here is used to represent an angle, and it's referred to as theta, which is just a letter from the Greek alphabet used to describe an angle. Then once you understand what the angle of inclination represents, then the main equation you need to know is m equals to tan theta, where m represents the gradient and theta is the angle of inclination. So the gradient of the line will equal to tan of the angle. So there's two possible cases. The first is where theta is an angle between 0 and 90 degrees, so an acute angle. And when the angle of inclination is an acute angle, then the gradient will have a positive value. Let's look at an example. In this example, you have the line y equals to 2x. So by comparing it to the general equation for a line, which is y equals to mx plus c, we can deduce that the gradient m is equal to 2. Then using the equation m equals to tan theta, we can say that tan theta equals to 2. Then the goal of the example is you need to find out the value of the angle theta. And how you do that is by taking the tan to the other side and making it tan inverse of 2. So then theta will equal to tan inverse 2. Then you just type that into your calculator and you end up getting the angle as 63.4 degrees, which falls between 0 and 90 degrees as expected, since we already knew the gradient has a positive value, and we could visually note that the angle is less than 90 degrees. Then the second case is for angles between 180 and 90 degrees, this being an obtuse angle. And when the angle of inclination is an obtuse angle, the gradient value will be negative. Let's look at an example with an obtuse angle. In this case, you have the line with the equation y equals to minus 2x. So just from the equation, we can tell that the gradient is negative 2. And m equals to tan theta, so tan theta will equal to negative 2. Then you can just calculate theta by saying tan inverse of negative 2. And this will give a value of negative 63.4 degrees. What are you supposed to do with this? We want an angle between 90 and 180 degrees. So what does minus 63, 4 degrees mean? Well, you don't need to worry so much about the technicalities related to the meaning of a minus angle. That's more for the trigonometry video. But for now, all you need to know is that to get the desired value of an obtuse angle that falls between 90 and 180 degrees, you add 180 to this minus 63, 4, which finally gives the obtuse angle as 116,6 degrees, which as desired falls between 90 and 180 degrees. And those are all the concepts you need to revise for this section. Then moving on to the first bit of new material, let's see how you determine the equation of a circle. So there's a nice convenient equation describing the graph of a circle using x and y coordinates. And this is the general equation of a circle, which is the following. X minus a squared plus y minus b squared is equal to r squared, where a and b are the x and y coordinates respectively of the center point of the circle, and r just represents the radius of the circle. So putting all this information together, the general equation of a circle is x minus the x coordinate of the center point of the circle squared plus y minus the y coordinate of the center point squared is equal to the radius squared. And there's two possible situations which you could be presented with, and those differ from each other according to what coordinates are chosen for the center point of the circle. The first of these is a nice simple case where the circle is centered on the origin. And the implication of this is that the coordinates a and b would just be equal to 0 and 0. And this simplifies everything because when you sub in a and b values of 0 and 0 into the general equation, you just end up with an equation of the form x squared plus y squared is equal to r squared. Let's look at an example. This example asks us to sketch the graph of the equation x squared plus y squared equals to 16. We know this is similar to the general equation for a circle, so a good idea is to compare them to each other. And by comparing our equation to the general equation in this way, we can deduce that the only value of a that will lead to this sort of equation is an a value of 0. And the only value of b that will lead to this sort of an equation is a b value of 0 as well. Meaning the coordinates of the center point of the circle are 0 and 0. So even though we know the center point of the circle, we can't yet sketch it because we don't know what its radius is. And we can determine that by comparing it again to the general equation. And through that comparison, we see that r squared will equal to 16. And since r represents the radius, we can solve for r by taking the square root of 16, which gives values of either 4 or negative 4. And we know that a circle can't have a radius of negative 4, therefore the correct radius value is 4. We now have enough information to sketch the circle, and this sketch looks like, where we can see the circle is centered at the origin, and then the radius would be 4, because it goes out to 4 in all directions. And that's the first case related to the coordinates of the center point, this being the simple case. Then the other case is the usual case, which is the sort of case you're more likely to see in tests and exams to see if you actually understand how the equation works. And the usual case is for a circle centered anywhere else besides the origin. Let's look at an example. This example asks us to sketch the graph of the equation x minus 1 squared plus y minus 3 squared is equal to 9. Then you follow the same first step as before, which is you compare this to the general circle equation. And this time our equation looks a lot more similar to the general equation. And by comparing the two, we can see that a would be equal to 1 and b would be equal to 3. Therefore the circle will be centered at coordinates of 1 and 3. And we now know where it's centered, then we just need to determine what its radius is in order to sketch it. And again, you do that by comparing the two equations and seeing what you have on the right side, which in this case gives us r squared is equal to 9. Then just solve for r by taking the square root of 9, giving us the radius as 3. Then we can just sketch the circle, which would look like, so we have our center of 1 and 3 over here, and it has a radius of 3. And it's important to note that the equation won't always be neat and look exactly like the form of the general equation. It could also have something such as an x plus some number or a y plus some number. So something like this. Let's see how or why this would occur with another example. Say you have a circle centered on -1 and -3 with a radius of 3. What would its equation be? It's always a good idea to first write out the general equation. Then in the previous examples, we were sort of already given the equation and then we had to deduce this information. But this example is sort of the opposite, where we're given the information and we need to deduce the general equation. It's pretty simple. A represents the x coordinate of the center, so A would be -1, and B represents the y coordinate of the center, so B would be -3, and they told us the radius is 3, so R is equal to 3. Then just sub these directly into this equation, which gives x minus A, which is -1 squared, plus y minus B, which is -3 squared, is equal to R squared, which is 3 squared, which will just give a value of 9. Then just basic maths, where both the negatives cancel each other out, giving the final equation as x plus 1 squared plus y plus 3 squared is equal to 9. So that example is just to show you that it won't always be x minus something and y minus something for the equation of a circle. Besides this plus and plus case, you could even have one of them being minus and the other being plus. It entirely just depends on what the values of the center point coordinates are in a specific case. Then the next thing to know is that a lot of the time you could be told the center point and then you'd be told the radius, but not as a nice number such as 3, but as a square root of something. But once you're familiar with the general equation, you'll recognize that in the general equation, the radius is squared. So in the general equation, that square root would be squared and you just have a nice normal number here. Here's an example. This question asks, what's the equation of a circle centered on coordinates of -3 and 6 and having a radius of square root of 17? So first pull out the trusted general equation. Then A would be -3, B would be 6, and R would be root 17. Then just sub these all into this equation, giving x minus -3 squared plus y minus 6 squared is equal to square root of 17 squared, which simplifies down to x plus 3 squared plus y minus 6 squared is equal to 17. Cool. So just get comfortable with this general equation and know what everything in it means, because you'll have to play around with it in a bunch of different ways. Here's another sort of question you could ask. The question asks, what's the equation of a circle centered on the point A with coordinates of -4 and -2, and with the circle having the point B on it with coordinates of -3 and -2? And when you're told that a circle has a certain point on it, it means that point lies somewhere along the circumference of the circle. It doesn't mean it lies somewhere inside of the circle or anything. It means it has to lie on the graph of the actual circle. And coming back to the question, they've told us the coordinates where it's centered, so we can automatically tell that A is -4 and B is -2. But this time they didn't tell us what the radius is, so we have to play around with the general equation to determine it. So first, just sub these all into the general equation, giving x minus -4 squared plus y minus -2 squared is equal to r squared, which simplifies to x plus 4 squared plus y plus 2 squared is equal to r squared. So we have the majority of the equation already. We just need to determine the value of r. And you can determine r using the coordinates of the point B. Since B falls on the graph of the circle, this equation should also apply to the point B. Therefore, you can determine r by subbing in B's coordinates into this equation. And when you do that, you get -3 plus 4 squared plus -2 plus 2 squared is equal to r squared. And through simple maths, you'd get a 1 over here and a 0 over here, leaving just 1 squared is equal to r squared. Therefore, r is equal to 1. then you can just sub that value back into this equation. Then you get the final equation of the circle as x plus 4 squared plus y plus 2 squared is equal to 1. We can now move on to the next section, which relates to the equation of a tangent to a circle.